All right. Good morning, everyone. Hello, programmers. How are you? How are you? Fine, okay. So I'm here to talk about functional programming in Java. Are you happy? But I will also show some Scala snippets, so that you can compare side by side. And I will be honest, this is a talk about functional programming, but I don't want to show you any math here. I don't want to explain why monad is a monoid in the category of endofunctors, and I don't want to even try to convince you that functional programming is cool. What I want to show you is some practical and applicable examples of how you can use functional programming to solve everyday problems, so that you can include it as another tool in your tool belt. So imagine that you are part of a remote team that does contracts for various clients around the globe. And one day, a new client approaches you, and he's from galaxy far, far away, and he heard about this thing called Twitter that people on Earth use. And he wants to have something like that in his own galaxy. And of course, we don't have any other choice, so we need to accept the contract, and we happily do so and promise to have a working prototype by the end of the next week. And we immediately go to our favorite coffee house and start hacking right away. And it turns out that the most important functionality, MVP, of this piece of software is to have a followers functionality. That means that our software needs to be able to show for each particular user how many followers does this particular user have. And we spawn our IDE, and because we are in the coffee house, we want to use functional programming. And what does it mean to be a functional programmer these days? So probably most of you know the answer. Usual ones are you need to use immutable collections, be able to create immutable types, and no reassignments, functions as first-class citizens, and of course, you need to be able to create functions that take functions and return functions as take functions as parameters and return functions, so higher order functions. And we have lambdas and streams since Java 8, right? So we can be functional programmers. Yes or no? T-shirt is here on the stakes. Yes or no? Where yes and no, so the wrong answer. And of course, lambdas and streams are there, and they are very, very nice. So streams help us build some higher order APIs, a little bit verbose, but okay, we can live with that. And of course, lambdas are very, very important because they bring functions as first-class citizens to the language. But the most important problem that still is there is the Immutable Collections API. The APIs haven't really changed, so we still have mutable collections. In order to use some immutable ones, we need to use external libraries like Guava. So the same cannot be said about Scala. In Scala, everything is built in. Everything functional is built into the language. So immutable collections, built-in immutable types using the case class notation, and higher order functions are a little less verbose. And in terms of basic functional programming, Kotlin is very, very similar to Scala. There are some more apparent differences on more advanced levels, which I will touch upon at the end of the presentation. But on the basic level, they are very, very similar. But I'm not here to talk you into either Kotlin or Scala. I'm here to talk about functional programming. And it turns out that we can use functional programming in Java today. There's this library called Vavr, which has just been renamed from Java slang due to trademark conflict with Java, of course. And all my code, Java code today, will use Vavr. So after including Vavr, we have some more abstractions we can work with, immutable collections, which are built in, and functions, which are wrapping the Java functions, and they work with immutable collections very, very nicely. So higher order functions, like in the example at the bottom, look more similar to those of Kotlin and Scala. So Vavr is bringing the ideas from Scala into Java world, okay? And a small disclaimer, I'm a Scala developer, so I picked up Vavr very, very quickly. But if you have any problems understanding the code on the slides, please interrupt me, I'll try to explain better. So after including Vavr, we have almost everything we need in order to really do this project. So a quick recap for all those guys who were late to this talk. We are tasked with creating a new application, Galactic Twitter, and this main functionality of this application is followers functionality. So our application needs to be able to show how many followers does each particular user have, okay? So let's start implementing that. Let's start with our domain. Simple, very simple abstract class, citizen, just a name. So this is our abstract citizen of the galaxy. We need to be able to model followers. And of course, followers are citizens of the galaxy. And of course, there is a civilian, which extends citizen, also just a name Jedi with a name, rebel with a name, Sith with a name, and finally, a stormtrooper, which also has a name, but also, additionally, it has this Boolean flag, which tells us whether this particular stormtrooper is a clone or not. We'll use that. OK. We also know how to fetch those guys from the database. So we know how to fetch citizen by providing just a name, and we know how to fetch the followers for a particular citizen. And both of those functions are implemented by one of our colleagues on the other side of the globe, and both of them return future. And what is this future type? The future type is from Vavr. And this models values that may be available in the future, or the computations that provide those values may fail. So 2 cases are modeled by the future. And this is the foundation of asynchronous programming in languages like Java and Scala. So what can we do with such a type in order to use that? So we are backend developers, so we need to create a backend backend server, and also for our debugging purposes, we need to create a console application. So let's try to create our console helper application. So first, we need to get this console from the console input. We need to get the name of the citizen, and then we are using this DB client function that our colleague implemented, which returns future, and we just get this future of citizen. What can we do with that? We press period in our IDE, and we get all the possible functions that we can use. And one of them is get. Get, what it does, it just captures, unwraps the citizen out of the future. So here we are able to get the citizen out of the future and use that. We can repeat the same procedure with the followers. So we just provide our citizen we just got from our future, and also call get on it, and we get the list of citizens, and then print them on the console. So we've done well, right? Or did we? So what's the problem? Because there is a problem there. Sorry? Who's saying that? OK, very nice, yes. So the thing is that if database is slow, please come to get a T-shirt after the talk. After the talk, OK? Thank you. So if the database is slow, the user thread will freeze, and then the user gets frustrated. So until we get this value from the future, the user thread will get blocked, and nothing will happen in the application. In order to keep the user happy, we need to feedback what's happening inside the application. So we don't want to block at all. So what can we do in order to not block at all? We can. In functional programming, there's a very, very common pattern, so we do that all the time. So we don't unwrap anything from the future as long as possible. So that's the main idea. And in order to do that, we are just providing the transformations using the map function. So map, what it does, it takes a function which is used to transform the data inside the future. So in this case, we are providing DB client get followers, because this is a function that takes citizens, and we get future of list of citizens, right? So we get future of future. So, OK, there is a problem there. And in order to solve that, we need to use flat map. So what flat map does, it maps and then flattens the whole thing. So 2 futures are replaced with just 1. And no blocking calls at all. We are doing all the transformations inside the future context. And what we use is we use flat map and map operations. And those are so popular. And the pattern of mapping and flat mapping is so popular that in Scala we have a syntax just for that. It's called for comprehension. So those 2 snippets do the same thing. One of them at the top is in Java, and second one is in Scala. And those guys are doing the same thing. So for comprehension, the language syntax at the bottom, what it does, it flat maps and maps. And that's all. It's just a syntactic sugar. It's very, very useful. So what can we do with the function that returns future? Because we get followers async, what it does, it returns a future, right? Future of integer. What can we do with that? In order to display to the user, even in the console application or in the REST service, web service, we need to somehow get it. And still, we don't want to block, because that's the problem, right? So in line 21, as you see, we have a function that returns an integer, not future of integer. So that's OK. That's what we want to do. And in order to achieve that, we need to we need to implement something like a cache. So in line 19, you can see a map from string to integer, which is a cache of currently fetched values. And every time somebody wants a new followers for a citizen with a provided citizen name, we just asynchronously in line 22 fetch the followers from the citizen, and for each, what for each does, this is a method on future, it takes a lambda, and the lambda is executed when future completes successfully. So in line 23, what we see is we are updating the cache. And this is non-blocking call. So in line 25, we get straight to line 25, and we just return the current value in the cache, which at the beginning is nothing. So get or else at the end returns the default value 0. And of course, the API assumes that the user will poll for this value, right? Because every 200 or 300 milliseconds, we'll need to poll in order to get a new value. So this is part of the assumption. And the map that we use in the cache, this is not the hash map from Java. This is a hash map from Vavr. And this is immutable map. So as you see, the put operation returns a new hash map. And the second important thing is that get operation returns an option. Option, it models values that may or may not be there, just as you have expected. So when the provided key is there, the return concrete type is sum, and whenever the value under the key is not in the map, then we return none. So that's what we use additionally from Vavr. So now our application looks like that. So at the beginning, we input Darth Vader and get 0 followers. Then Luke Skywalker 0 followers. But at the second Darth Vader call, we get 102 followers. So that's how the API works. So there are several threads underneath. So for each, when it's calling our lambda under the hood, there's a new thread spawned. We don't have to do it by hand. We don't have to synchronize anything, any locks. So that's the power of immutability and future in concurrent programming. So this was just a console application. And as you see, the web application is also being developed by some of our colleagues. And the real web application knows about the assumption of polling. So the application is polling every 200 milliseconds and updates the value that is returned from the backend service. Okay? So but the backend is non-blocking, very quick. And there is some database call and cache in another thread. So our application works fine. Everything is going very well. But one night, our telephone starts ringing. And this is our client, and he's not happy, and he files a bug report. I have 0 followers. It's not possible. OK, so we know Darth Vader is not a very patient man, so we just run to our desks, fire up the console helper application, and run the query against production database, because why not? And try to find out what's happening. And we input Darth Vader, 0 followers, Darth Vader, 0 followers, 0 followers. And after 10 or 15 seconds, we get the real value of followers. So what happened? What happened? The problem is that the database is slow. So that's the one problem we need to address. But the second problem, and in my opinion, most important one, is that our application assumes that 0 is 0, either 0 followers or no value yet. So our 0 models 2 possible things. Okay? So we need to fix that. And in functional programming, in strongly typed functional programming, what we use, we try to use data to model everything. So we try to use types in order to model our assumptions about the API. So what we need to do is we need to have explicit return type. And what can we use in order to explicitly model something that may or may not be there? We use option type, which I have introduced earlier. So option, what it does, it models 2 possible values. It has 2 concrete subtypes. One is sum, when the value is present, and second one is none, when value is not present. So let's change that in our application. And as you see, there are not many changes. One of them is in line 33, when we change integer to option of integer. And the second one is line 37, because we got rid of get or else call. And we just return get. We just return what get from the map returns. Okay, so not much changed, but now our API assumes something about our return type includes the assumptions about the API. And of course, we changed the API, so we need to update web application. And now the user knows what's happening inside. So every time none is returned, we just display loading. Whenever sum of integer is returned, we just display this integer. And everything works fine again, but one night our telephone starts ringing. And it turns out it's our client again, and he's not happy, and he files a bug report. I can't check how many followers does Obi-Wan Kenobi have. Okay, so we run to our desk again, fire up our helper console application, which turns out to be very, very helpful, and run a query against production database. Okay, and we input the Obi-Wan Kenobi, which was provided by Darth Vader. Obi-Wan Kenobi has loading followers, loading followers. After 20 seconds, 1 minute, loading followers. So what could possibly happen? Another T-shirt to be won. Database is too big? Okay.
There is no Obi-Wan Kenobi.
Artur?
No followers of Obi-Wan Kenobi. We don't know that we are zero. We are waiting just for it.
Okay, guys, so Obi-Wan Kenobi is misspelled. And it turns out our application, our DB client, which was not designed and implemented by us, throws exception every time the citizen is not found with the provided name. And Obi-Wan Kenobi needs to be spelled with capital W, not the small letter like here. So Darth Vader made a mistake. And I probably used some URL hacking. But OK, let's leave that alone. And as we may have expected, there is some problem. Whenever the future fails, we don't really have it covered, because for each, what it does, it only executes our lambda that we provide when the future completes successfully with the value we expect. In this case, result in line 34 is expected to be an integer, right? And the failure, like this one, may be also an exception that is thrown due to technical reasons, like timeout or any other network problems. So we need to be able to handle future failures. So what can we do? In strongly typed functional programming, what we use, we use data to model everything. So we use return types in order to model our assumptions about the API. In Vavr, we have this try type. And this try type models exactly what we need. It models a successful computation, and then provides the value of type T, and it models failure, and then it conveys the exception that was thrown when the value was being computed. And there are some similarities to option because the structure is very, very similar. So let's try to do that. Let's try to change our application in order to solve the problem with failures. So in line 29, guys, can all of you see the code? Not really. Let's change it then. I know. Not a problem. Not a problem. Okay, there's a problem. Can you see it now? More? More? Okay. No, doesn't work. Sorry about that. Okay, now? I hope that's okay, because I won't be able to program if it's any bigger. Okay, let's try it this way. Okay, so private static map. Here's our map of cached followers, and we can see that we are using this integer here. And here's our function get followers async. Okay, and in our main function, what we are having here is we are trying to get the followers asynchronously, and then we are updating the cache here. Okay. So we are putting, sorry about that, we are putting followers in our map, and then we are trying to display it. Okay, it's very, very big. Sorry about that. Okay, so we are putting citizen name and followers, and then getting getting the value from the cache and displaying it in the console. So in order to see the exception, let's comment this one out and write a new one using some synchronous version, because we want to see the exception, okay? So in order to see the exception, we will use the synchronous version. The synchronous version is the usual one with the gets I shown at the beginning. So it will block the user thread, but we will be able to show to see the exception. So string followers text and get followers synchronously, and we are providing the citizen name here, and it fails because we need to string it. And that's all. So let's see it running. And we'll try to provide a misspelled version of Obi-Wan Kenobi. Obi-Wan Kenobi. And as you see, the thread is blocked, and then we get this exception. And pay close attention to this exception here, because this is the last time you see this red big error, because I will show you some kind of trick using the try type. So what we need to do whenever we have a code that throws an exception, may throw an exception, we may wrap it inside of try. And then we need to have a runnable. So this is a runnable lambda, right? And that's all we need in order to implement that. So try just wraps the function call, and that's all. And let's run it again now. And now our application will not fail with an error. Okay? This will just move the exception from the exception throwing mechanism to the types, to the type system. So we'll be able to see the failure, to see the exception, but it's not thrown. It's part of our type. Okay, so that's how it works. And this is just a synchronous version, and we can do the same in the asynchronous version. So future followers get followers asynchronously, and follows text. So what we need to do is we need to change this for each to what? To something different, something that also tells us whether there was a problem or not. And as you see on complete, we need to provide a lambda which takes a try. So here followers is not followers anymore. It's just something that is called tried followers, because this is the type. I will just show you that. What's the type of tried followers? The type is, we won't be able to see that, try of integer. So right now this try of integer, we have a compiler error because our cache is from string to integer. So what we need to change here in order to make it compile? Try. Yeah, thank you. That's all. Now it should be compiling fine, and let's run it. Darth Vader, non-followers, Obi-Wan Kenobi, non-followers because it returns option, and then when we put Obi-Wan Kenobi again, we get some failure. Yes, so it's better, but we are not there yet. So let's try to do it even better. So in order to make it even better, what's the type of cached followers? Get. So what's the return type of here? The cache, the map is string to try of integer. So get returns option of try of integer, right? So we can map inside this option and have tried followers tried followers to string, and then get or else loading, so that we can see what's happening. So that's what we do. We don't unwrap, we just map it and then get or else. And let's see. This will be the last part. Darth Vader, loading followers, Obi-Wan Kenobi, loading followers, and Obi-Wan Kenobi again should be an error. You can see failure, but when we put Darth Vader, we get success of 102. So probably somehow better, but we'll see how it works then after more changes. So what we did, we just used the try type. And let's recap. So we needed to change, sorry about that, we needed to change the type in line 44 of our cache from integer to try of integer, and we needed to change in line 47 the for each to onComplete. And we use this onComplete function from future in Vavr that gets try and what it does, it executes this function that we provide anytime the future completes, either with failure or with success. Okay, so now in the function signature in line 46, the user, the client of our application, can see what are our assumptions, because option means that the value may or may not be there, and if it's there, it may be failure or a success. So that's what the type conveys. And the cool thing about this type and many others is that in our example, we have two futures which may fail. But when we flat mapping and mapping all the things, we can just handle the failures at the end, only when we need the final value. So one failure handling and two possible failures. So that's very, very convenient. Of course, we can have more than that, but at least in order to have a resilient application, we need to handle them once. So all of this is encapsulated in try type, including the exceptions. So exceptions are not thrown anymore. They are just inside the type system. So we changed the API. We need also to change our web application. And now, as you see, whenever none is returned, we still display loading. But whenever sum of something is returned, sum of success, we display 102. When sum of failure is returned, we just update the GUI so that the user don't see the exception. Of course, it would need to go through our UX department, but yeah, for now it should be okay. So now the user exactly knows what's happening inside the application. Everything works fine, but one night our telephone starts ringing, and this is our client again, and he files a bug report. I am not happy with the return types you use in the application. Okay, but then suddenly we wake up and realize that was just a nightmare, so that's good. But then we start having some second thoughts. Maybe this was a sign. Maybe we shouldn't be using such cryptic return types in our application. Maybe there is a problem. But what about modeling everything with data? What about modeling our assumptions about the API with return types? So we want to have a cake and eat it too. And that's where ADTs, or algebraic data types, come into play. So algebraic data types are plain types, either product or sum types. Product types are just types that consist of several types. For example, if you create a class with string, boolean, and integer, then you just created a product type of string, boolean, and integer. On the other hand, sum type is more similar to enums, so it may be just one concrete type at a time. Sorry. So we can, of course, mix them together. And we have already seen some ADTs, like Stormtrooper is an ADT of string and boolean, and Citizen is a sum type of civilian, Jedi, rebel, or Sith, or Stormtrooper. And try and option are also ADTs, sum types. So try is success or failure, option is sum or none. So sum types. So let's model our assumptions about the API using ADTs. So let's create in line 57 our remote followers data. And then we need to create some concrete types. This is our sum type that consists of 4 possible concrete types. So not requested yet is something that tells us that the value has not been really requested, and we don't know what it may even be. And the loading is we requested the value and waiting for the response from the server, from the database. And failed is whenever the computation failed, we get an error message as a string, and fetched, we get the integer of followers. So this is the successful case. So this is our model. And then in line 78, we can use that instead of our cryptic return type, right? So get remote followers right now returns remote followers data. And there are some additional amendments in the code. As you can see in line 79, we need to check whether the cache is empty, and then we put loading in it and asynchronously try to fetch it. And we use onComplete, so we get try of followers. But then in this blue big rectangle, we need to somehow decide what to do with this try of integer. This is try of integer that we need to convert into an instance of remote followers data, which may be one of those concrete subtypes, right? So based on the try of integer, we need to decide what to do, what type, instance of what type to create. And yeah, so how can we really convert try of integer into remote followers data? It turns out that there is a technique that we can use. It's called pattern matching, and it is supported in Java through Vavr library. And ADTs can be decomposed. Algebraic data types can be decomposed using pattern matching. Some types can be decomposed using case here, in line 83 and 84, and product types can be decomposed using this crazy dollar sign. And of course, before you burn me alive, I will try to show you that in the code, of course. So let's see what we had so far. So as you see, we got loading and failures here, but still Darth Vader has success 102 followers. Success 102 followers. So that's a problem. The same problem, but simpler, because we want to have this live coding very, very brief. So what we need to do here is we need to convert the try of integer into a string, but a nice string. If it's a failure, we need to say that it was an error. But if it's a success, we just need to have this 102. So we want to have Darth Vader has 102 followers, okay? And of course, the problem can be dealt with using pattern matching. So let's try to do that. Here, we have this map, and we have tried followers. Tried followers is of type try of integer. So let's match it. Let's match tried followers. And there may be several cases. The first case is that it may be a success. Success, okay, here, okay. And the second case is, so ADT. Try is a sum type which consists of two types. One of them is success, and second one is failure. So when we do pattern matching, we do a very similar thing. It is just like that. So it's still not compiling, because what we need to have here, in order to put a nice string, we need to have a string of 102 or any other integer that is returned. So we somehow need to get followers count here and just to string it. Okay? But how we get these followers here? The case consists of two parts. The first one is a pattern, and second one is the function that is called whenever this pattern matches. So in order to get these followers, success conveys the type of type T. In this case, it's integer. And we need to use this dollar and extraction from success in order to get it to the followers. The same here, we need to use this extraction in order to get the exception, because failure has an exception. And we just can do something like that. Error, string, and x to string. So that's how it works. We can format errors like that. And I had a typo here, so let's get rid of that. So that's all we need. So that's the pattern matching. We created a new value of type string based on type try of integer. And now when we provide ob1 Kenobi Darth Vader, you can see that it's still non-blocking. We have an error here, because this is what we created. And Darth Vader is 102 followers, so that's what we really meant. So we based on try of integer, we created a new string. So let's go back to slides and recap a little bit. In order to create the remote followers data value, we need to, based on the try of followers type, we need to extract the values from it. And in line 83, create a new fetched with the integers using the lambda conversion, lambda reference method. And failure case in line 84 is just extracting the exception and then creating a new failed with the error type, okay? And now we know how to handle the remote followers data that we have in our API. So we have a sum type with 4 possible cases. So we need to have 4 possible cases, and based on that, create strings using some extractions, but not requested yet, and loading, as you see, they just return a constant value, okay? So in Scala, both ADTs and pattern matching are included in the language. Sealed trait is an interface that can be just defined and redefined in one file, so that nobody can really change that besides us. And pattern matching looks very similar, but it's included as language syntax, okay? So everything works fine, but one night, our telephone starts ringing. And this time, it's not our client, it's our user. It turned out that our application has become...
Does Vavr future currently support success on failure from chaining the...
Sorry? The question?
The Vavr future
Yes, yes. It supports on success and on failure. Yes.
So is there a reason to use this on complete instead of this?
Only when you there is a reason to use on complete here. Okay, so let's go back a bit. Only if you really want to have a very nice concise solution to one of your problems. So there is just one call, and there is a type which conveys both failure and success, and you can pass around the try type instead of doing on complete, on success, and on failure in different places in your code. So try what it does. It has all this information inside. Okay. Okay, so the problem here is that our application has become very popular, and the follower count has been used as propaganda tool. And the user is part of a rebellion, and he doesn't like how many followers Darth Vader have. So he says that clones should not be counted as followers. And we fire up our computer and see in our IDE that it is a case. So our functionality of counting the followers is, as you see on the screen, so just the size of the followers. Nothing more. So user is right, it's a bug. Clones should not be counted as followers. So let's change that. And in order to change that, we can use this count method, which is in Vavr list. So what count does, it takes a lambda. And this lambda is executed on every element of the list. And this lambda returns true or false, and all the truths are counted and then returned here. So there's a predicate, right? And we need to create this predicate and pass it to the count function. So let's find out what should be this lambda that we need to provide to this count. And so the counting of followers, we need to return true in this lambda whenever there is a civilian, Jedi, rebel, or Sith, or a stormtrooper that has a flag is cloned set to false. So what can we use in order to solve that, in order to write this lambda? Who knows? Another T-shirt to be won. Pattern matching to the rescue, of course. So what we can do is we can match on this on each of the followers of the citizens, and then in line 18 we can, for the stormtrooper case, we can just extract some name and then extract a value or pattern match a value which is true. So we can see you can also use in line 18 just true. So every time there is a stormtrooper which has a true set as a is clone flag, then we return false. And in any other case, line 19, it's any other case, we just return true. Okay, so that's how it works. And it looks very similar in Scala. So we have two cases. One of them is for true, and second one is for any other thing. Little less verbose, but almost exactly the same. Okay, cool. Again, everything works fine, but one night our telephone starts ringing, and it's our client again, and he's not happy with our application being used as a political tool for political purposes. And he files a feature request. So he says that some of the tweets are political, and we go through the feed currently that is on this Galactic Twitter website, and we can see that some of them are really rather political. So a user is probably right. We need to implement this new feature, and user suggested what this feature may be. This feature is called censorship module. So in order to make Twitter less political, we need to include a censorship module. And the user provided us with a list of filters. And each filter consists of condition. So each tweet will need to satisfy this condition in order to be manipulated. And then the manipulation algorithm, like if the tweet is pro-dark side, this is the condition. Manipulation is we need to add more dark side to it. And we don't want to delete it, just manipulate them. So there is an initial list, which is not very important. The most important thing is that there should be no more than 2 manipulations done for one tweet. So client provided this with initial list, which may change. And we started to implement that like very naively. The first approach is that we can use if block, right? So we can use if condition is satisfied, then we manipulate. And we need to keep an eye on manipulations. So we need to increment manipulations and check in lines 24 and 28, check whether we have exceeded the number of censorship manipulations or not. So to implement all 8 initial filters, we need to do something like that. You don't want to really read it, and there is lots of ifs, big block of code with mutable state and and so on. So can we do better? It turns out in functional programming, in strongly typed functional programming, what we want to do is we want to model everything using data. So we want to use types to model even our algorithms. In this case, we will use the sensor filter type, which has two types, two fields. The first one is function from tweet to boolean, which is our condition, and second one is tweet to tweet, which is our manipulation algorithm. So what can we do with such a type that consists of two functions? We can create a list of it, right? So this is a real Java code. As you can see, this is the initial list that Darth Vader provided. So all the initial filters are there. So this is just data, pure value. Can we execute data then? Can we execute this list? Where it turns out we can execute lists. The technique is called folding. So what we want to do is we want to fold all the values in the list into one output value by providing the initial aggregator, in this case original tweet, which will go through all the items in the list. And for each item in the list, then the function that we provide, the second thing we provide, the function is called. So tweet and filter to a new tweet. So a function that composes the current aggregator and the current element of the list. And it goes like that until we get a final value. So in order to give you some perspective, let's see an example on ints. So the initial value is 0. The list of ints is 4, 6, and 3. And then we get 0 plus 4 with our function that we provided, which is just summing two things. So we get 0 plus 4 for the first element, then 4 plus 6 for second element, and for third element, 10 plus 3, and we get the final value. So we folded the whole list of ints into one value, which is 13. And we can use fold left. Fold left is another thing in Vavr list, which we can use. This takes two parameters. The first one is initial 0 parameter, and second is the function and that we need to use in order to aggregate those values. Okay? So in our case, this would look like that. So we need to create this apply filter function, which takes tweet and filter, and based on whether this tweet should be manipulated, returns a new manipulated tweet, and in other case, else it returns the current tweet. So it folds the tweet, the list of filters with the current original tweet, and we get sensor tweet in return. And of course, we need to keep an eye on our additional requirement, which is two manipulations at once. So in order to do that, we need to also include that in the type, and we'll call this type sensor status. It will consist of tweet and number of currently made manipulations. And the implementation needs to be changed a little bit. 104, you can see that status manipulations needs to be smaller than that. And this one big block of code has just been replaced with one function, and two lines of initialization. So line 96 sensor status is new sensor status with original tweet and 0 manipulations, and then we just fold left with the function that I have just described. And that's all we really need in order to do that. So we use data and pure values, pure functions in full glory. We don't use anything more. And the cool thing is that we can use a feature switch. So whenever rebellion starts winning, we can just replace it with rebellion filters, and possibly it is just an empty list. Let's hope so. But other than that, we don't really need to change anything more. So that's what we can do. And again, everything works fine, but one night our telephone starts ringing, and this is not our client, this is not our user, it's Uncle Bob. And Uncle Bob says that we don't have any tests. He thinks that we don't have any tests, and he's right. So we don't have any tests, but I have been talking about this modeling everything with data so much time, and you haven't asked why do I want to do that. And now is the time that I can explain you why. Right now is the time that it pays off. So standard unit test. Imagine that you want to create a unit test for your functionality of counting the followers. So we need to be able to count only the non-clones, right? Non-clones. So the standard unit test may look like that. The first one equals that we provide an example. Example is a list of 3 stormtroopers, and then we just assert that 2 of them should be counted as followers. And another example and another. So this is a very, very small functionality, and even those 2 cases, those 2 unit test examples are not enough in order to cover every possible case. So yeah, we can do better. In strongly typed functional programming, we use data in order to model everything, and then we can test this data using properties. So in order to test something, we are lazy programmers, it's perfect for lazy programmers to just provide a property. And then out of this property, that framework will generate all the possible corner cases that we may have never thought of even. So in this case, I'll just show you how to write 1,000 tests in, I have like 4 minutes left. Okay, so let's try to do that. 1,000 tests. I will show you how to do that. Yeah. Cool, thank you. So first, we need to create arbitrary values. Arbitrary are things that are used by Vavr framework in order to create values, random values. It needs to be able to create random values. So first is clone, and based on arbitrary integer, we just create a new stormtrooper. Stormtrooper which has a name, clone plus ID, and true, right? Because it's a clone. And then we can stormtrooper. Okay, and then we can create a new, sorry about that, a non-clone, like here. I will just show you. Sorry about that. Non-clone like here. Arbitrary integer, stormtrooper with false. Sorry about that. It should be map here, because what integer does, it returns a random integer, right? Then we need to map it. Here we also need to map it with this ID, and we have two possible arbitrary values. And then we need to be able to create a list. So line 40 is arbitrary list of clones based on this clone that we provided. And then we just define our property. Our property is count followers, clones, and plus non-clones should be equal to count followers on non-clones. So this is our property, okay? Count followers of list of clones and non-clones should be equal all the time for every possible input to count followers of non-clones. So for all possible values, this is a Java code, of clones and non-clones, such that we provide lambda, count followers of C append non-C should be equal to count non-followers of non-C, okay? And then we just check, and assert is satisfied. And then we can write it, and we get property test, like 1,000 tests in 7 lines of code, okay? So that's how it works. So let's recap. We needed to provide arbitrary values in order to generate the custom types, and integers and lists are provided by the framework because they know how to create it. We need just to provide how to create our own types. And then we need to provide for all and such that, like the case, the property is checked, and then the framework generates all the possible corner cases in order to check our property.
Where did the 1,000 come from?
The 1,000 default value. You can do whatever you want. This is the default value in this library. So now everything works fine, and our telephone is not ringing. So this was Pragmatist's Guide to Functional Geekery, starring Coffee House programmer, Darth Vader, Luke Skywalker, and Uncle Bob as guest star, and directed by future type, which models values that are maybe available in the future or may fail, option type, which models values that may or may not be there, and try type, which models computations that may fail. And all of them can be treated as monads because they have flat map operation. Special effects, algebraic data types, which help us model more complex reality, pattern matching, which helps us deal with the algebraic data types, which may get complex, and property-based tests, which help us write tests using properties, not examples. And all the code is available. The screenplay for this talk is available at this Galactic Twitter repository. There is Java and Scala implementations of the same application, so you can use it. And there is a web server implementation in HTTP in both Scala and Java. Pattern matching, how it's implemented, you can see there in the code. There are lots of comments and readmes, so please take a look. Also, there is a type class pattern, which you can use in order to get rid of all your annotations. In Scala, we don't use annotations, we use type class pattern. And pimp my type pattern helped me create a nice predicate logic in the censorship module. And main takeaway from this presentation, in functional programming, everything should be modeled as data because it is more maintainable, more testable, and really easier. We can easily reason about that. So your main takeaway is that in functional programming, we want to have everything as data. And there are some techniques like this basic one I showed you and many other ones that will really help us do just that. Thank you very much. This is, I'm Michał. This is my blog. This is my Twitter handle. So if you have any feedback, just please go there or ask me anything here. And have a wonderful second day of the conference. And remember to model everything as data. Thank you very much.